Okay, to answer a question I got by email, if you take a look at the question was in the delta configuration, y is v phase equal to v line. So let's take a look at the delta configuration right here, and I'll look at V12. So V phase is the voltage across that V12. So V12 is V phase for delta. So V phase for the Y over here would be the voltage between, say, these 2 points. So it's the voltage between two of your vertices on your triangle for delta, and between the end of your Y and the center for Y. So that's V phase. But then V line is the voltage between lines. And so here is line 1, here is line 2. So the voltage between these lines is the same as the voltage between these points. So that is true for delta. Now it's not true for Y, because if you look at Y, the voltage between these 2 points is not the same as the voltage between the 2 lines, which would be line 2 is here and line 1 is here, and so the voltage between those is not the same. But it is true for delta. The next question had to do with where did the square root of 3 come from? So first let me talk about where you see the square root of 3 and then I'll briefly tell you where it comes from. So if you are looking at a Y system, then you have the neutral in the middle, and you have your voltage on the phase is the voltage from one end to the middle, and your line voltage is your voltage between lines. And so it makes sense that your line voltage would be bigger than your phase voltage, because you've got your voltage from here to here and your voltage from here to here, and so that would be your line voltage would be the difference between those. But for a Y system, your line current is the same as your phase current, because your line current is just the current along these branches. And so for a Y system, and I'll come back and show this in a minute, for a Y system, your phase current equals your line current, but your phase voltage is the line voltage divided by the square root of 3, or the line voltage is the phase voltage times the square root of 3. Now for a delta, you can see that your phase voltage is going to be the same as your line voltage, because the voltage from here to here is the same as the voltage from here to here. But your line current is going to be different from your phase current, because if you look at the line current, the line going this way, if I had the phase current is the current here, and it gets here, and some can go this direction and some can go this direction. And we have contributions from all three lines. And I guess I probably perhaps drew this the wrong way. I guess I'm not sure what direction. Let's see. Yeah, I drew that wrong. Let me redraw that. So phase current that way, phase current that way, phase current that way, the line current that way. And so when you look at it like that, you can see that the line current is going to have to be more than the phase current is going to be, because if it was exactly equal to the phase current, then it would be the same as this, but then you also have this part to take care of. So the line current is going to be greater than the phase current, and the line current is going to be square root of 3 times the phase current, but the voltages are going to be the same, and that's for delta. Okay, so for Y, the phase current is the same as the line current, but the phase voltage is the line voltage divided by the square root of 3. For delta, the phase voltage is the same as the line voltage, but the phase current is the line current divided by the square root of 3. And then the other place the square root of 3 shows up is here with the power. We've got that, and that's the square root of 3 times the line voltage and line current. You take that and multiply by the square root of 3 to get the power. If you had, let's say that I had the phase current and phase voltage for either delta or Y, and so I find the power, and I'm just going to say the real average power. I find the power in one of these branches, and so the power would be the current times the voltage, but I've got 3 of them, so I'd multiply by 3, but that's phase. So depending on which configuration I have, one of these things is the same as the line, but divided by the square root of 3. And so that just depends on which configuration I'm in. So if I had 3 over the square root of 3 times square root of 3 over square root of 3, I'm just rationalizing it, I can see that that equals the square root of 3 times I line V line. So that's where that comes from. But I didn't mention where the square root of 3 came from in the first place. So remember that these things are 120 degrees apart. And remember that cosine of 120 degrees is 1/2, and sine of 120 degrees is square root of 3 over 2, except one of these is negative. But these are various multiples of 120 degrees. Did I have those right? Yeah, I think so. Okay, but it's this square root of 3 that's showing up when you're finding the difference between the two parts of the network. And if you look, there's plenty of places where you can find the derivation to see exactly where the square root of 3 comes from. But that's where it comes from. It's because the cosine, the sine of 60 degrees is square root of 3 over 2.